In the last lesson, we've learned how to draw and rotate a sphere. But spheres are special because they always have the outline of a circle, no matter how we rotate them. Other shapes don't work this way, so in this lesson we'll learn how to draw them. First, let's take a look at an ellipsoid. It's a 3D oval. An ellipsoid may look like this in the side view and like this in the front view. So when you rotate it to the left, its outline will gradually transition between these two views. So you not only have to take care of these inner curves, but you also need to remember about creating the proper outline. And this alone is simple enough, but another problem occurs when you want to rotate the ellipsoid in two directions. So let's say we want to rotate this ellipsoid down, which is pretty easy to do, and then we want to rotate it to the left. Because it's rotated slightly down, its whole outline should also be rotated slightly down, and the shape of this outline should be similar to the one on top, because they're at the same stage of rotation towards the front view. If you draw a sphere in the same position, now you turn this line into this curve. But here this line turns into this weird curve, so let's draw it in two halves. This part will be more similar to this curve, and this part will be more similar to this curve. And only now you can move the points along it just as you would on a sphere. The top point can be moved the normal way, and then you can create the axis and the curvature of the surface. So this is how to draw an ellipsoid, but there's also another method. You can just draw one sphere, then attach another sphere to it, and then simply simulate the axis, outline everything, and add the curves. It may not be perfect, but it will serve its function well. Let's talk about planes now. A plane is like a sheet of paper. It looks like this in the top view and like this in the side view. So when you draw something in 2D, this is the ground level. A plane is very useful because when you rotate it, you can easily place your animal on it, and then you can just copy its axis to create the view you want. So let's see how to rotate such a plane. When you rotate a sphere, one of its inner circles may look like a flat line at first, because it's straight in front of the viewer. When you rotate it down, it starts gaining more and more of the surface until it moves 90 degrees and reaches its full potential. So this works the same with the plane. It lies flat when in front of the viewer, and then you can rotate it more and more until it can be seen at full length. So this is how such a rotation looks in a flat ellipse, and here's how it looks in a plane. But this is a pretty boring view. It allows you to see the top and the side of an animal, but we want to see the third side as well. So let's rotate it to the left. If you wanted to rotate a sphere this way, first you'd rotate it down to create a curve that would help you with the position of the points once you move them to the right. Do the same with a plane. Rotate it down first, and then draw this ellipse inside it. Just like with a sphere, you can now drag your point along it, adjusting the distance to the degree of rotation. And once you have it, you can just use this curve to find the angle of the other axis. You need to estimate its length as well. The closer it is to the horizontal position, the more similar it will be to its full length. Now you can just connect these lines to create the outline of the plane. If you decide to put an animal on it and copy the axis of the plane, you'll see the body in the same orientation as the plane. And if you want to turn this plane into a box, you can just draw vertical lines under it and connect them. But just like the inner circles of a sphere are affected by their distance from the viewer, the edges of the plane can be affected by this as well. So this edge is closer to us than this one, so this one should be shorter. And the farther the other one is, the more dramatic the difference should be. It works the same in more rotated views, but here it's easier to just imagine that all the parallel lines are going to meet in one point, somewhere outside of the canvas. If you don't like this effect, don't worry. Most of the time it's not really that noticeable, so you can safely ignore it and leave it for the super dynamic views. That would be all for now. As an exercise for this lesson, I'd like you to draw a couple of ellipsoids and planes in different views. If you want, you can also draw a whole sheet of 16 views for each, but it's completely optional and only if you want to make sure you understood the process. So today we learned how to draw more complex 3D forms, and next time we're going to learn how to draw multiple forms in the same scene and keep everything consistent.